But gradually as a land. So what is animal and what is in a flower? So, so land in the past. So this guys learned in the past, and by with the knowledge. So this is called knowledge. So you can say that whether that image is consisting of animal or not, right? But by birth, when he born, he don't know what is animal, but what is a flower. But maybe in his experience, he might have seen so many animals or so many flowers. So when he has seen the image, then he can recollect from the brain, and he can what you say that he can identify that, right? Now, so this is called a given image. We are classifying into the either S class, S category, or we are classifying into the no category. So what this guy is doing, typically a classification task. What this guy is doing is a typically a classification task. Means what the classification task now? So given an image, you have to say that which category it belongs to, whether this image belongs to the animal category or the flowers category. If it is the animal category, say yes. If it is it is not animal category, if it is the flowers category, say no. Animal or not animal, right? Yes. So far it is good, but here if you look at this person, is good enough, is a good enough, and he's having enough knowledge. But how he has learned this knowledge? This knowledge is acquired in the past, because in the past he might have seen so many figures or photos related to the uh, flowers and animals. So with that knowledge, he can do this task. Now the same thing, the same task I can suppose there is a chest X-ray, and this chest X-ray is given to a doctor. So based on by observing this, a pulmonologist, you can say some specialist. So you can say yes or no. It means whether it's a COVID positive or COVID negative. So given a chest X-ray image, the doctor is classifying whether this image is belongs to the COVID positive class or a category or negative category, isn't it? That's what is. So here the doctors is doing the classification task, or you can also say that he is taking some decision. The decision making, he is doing a decision making. Here also, this guy is making the decisions. He's making some decision, right? What is the decision? So whether the particular person is having COVID or not by looking at this. So here the doctor is doing the classification task. In the same way, this guy is also doing the classification task or decision making. So suppose what suppose there is a stockbroker. He is a stockbroker, okay? So what the stockbroker, suppose I said that what could be the expected price of TCS stock or some HDFC stock, HDFC stock or SBI stock. I asked stockbroker, and with his knowledge, because he has been with the stock market, also in the stock market environment, with his knowledge, suppose he say that the expected stock value of the TCS could be, yes, Nana? Sridevi, what's so the expected the stock value? Suppose they are saying 2,300 rupees. This is the expected stock value, right? If you look at here, the stock broker is with the help of suppose today I purchased 2,200 rupees. I purchased the stock, two or the TCS stock, and I inquired the stock broker. So can I sell it or not? So means suppose the stock broker is saying that the expected stock market price of TCS stock price is 2,300, means there is 100 rupees profit. So you are making a decision with the help of this output. Now you can do either sell, can do a sell or you will not sell, selling or buying. So based on this information, you are making a decision called either sell or decision buying. So this is again a decision making process. If you carefully observe in the stockbroker case, in the stockbroker case, the output we are saying, so given a stock market input, some based on this knowledge is predicting a quantity which is a continuous quantity, a numerical quantity, which is a numerical or a continuous quantity. What does it mean? The stock market could value could be 2,300 or 2,301. It could be any value. So 2,301 or 2,500, it could be any value. So there exists a value for a continuous quantity. But where in the case of classification, the output quantity is fixed, whether it belongs to yes category or no category. There is no in between. So that's the reason the output in this case is a discrete quantity. In this case, the output is in a continuous quantity. Output is in a continuous quantity. So when the output is a continuous quantity, so this problem is called regression task. And if the output quantity is a discrete quantity, so this problem is called a classification task, classification problem or a classification task. So there are problems which can be classification problem. Some of them can be classification problem. Some of them can be the regression problems. And there are other things like dimensional reduction, anomaly detection, clustering. There are so many problems will be there. Okay, rule mining and but I'm not into so. Apart from this, there are other problems also there. They're given a problem, it's a classification problem, the regression problem. You have to identify which problem you are solving. So how to identify the problem? If the problem is to the output quantity we have to predict is a discrete quantity, then it is a classification problem. The quantity which I want to predict is a continuous quantity is in a regression problem. So let us check it, okay? So whether, suppose, so there is an Indian Meteorological Department, weather forecasting department in Visakhapatnam. Suppose I ask the query to them that is there rain tomorrow? So when they say that, they will say either yes or no. They will say either yes. Is this a classification or regression problem? Guys, is this a classification problem or regression problem?
Classifications.
Very good. It's a classification problem.
Yes.
Now, the same IMD, I asked the query, what is the expected temperature tomorrow. So the IMD is replied, so 30 degrees Celsius. The query you have given is what is expected temperature tomorrow, and the answer is given 30 degrees. Is this a classification problem or regression problem?
Regression problem.
Regression.
It's a regression problem. Very. See, both are the output is given by the same IMD, Indian Meteorological Department, but in one problem, I want a yes or no answer type response. In another way, in another problem, I want a numerical quantity as my response. So depending on that, we can say that it's a classification problem or a regression problem. Now, so these are two problems are there. Now the question is, let me come back, okay? Yes. Let us come back to the first problem, first case in the classification. Yes, here. Yes, here. Suppose I have given one image, okay. Suppose if I given 1 lakh images, if I given 1 lakh images, 1 lakh images, what will happen to them?
ఈ క్యాడ్ ల్యాబ్ లో కూర్చుంటున్నారు ఆయన
If I given 1 lakh image, yes, this
అది
person will
idea
classify,
VLSL.
but takes a lot of time. Do you agree?
Yes, sir.
If I whatever the classification task is performed by this person, he has to, by looking at the image, he has to say that is a containing animal or not. Yes, he will do, but it takes a lot of time. So lot of time. This is no doubt in that. It will take a lot of time. But maybe by overlook, sometimes sometimes this person may do wrong per classification also. Means there is a chance for mistake or errors. Humans will do mistakes sometimes when you overlook, okay? You may, because you may not see the image properly, you may classify. So we can say that if humans are involved in the decision making process or classification task or in the regression task, if there is humans that are involved, requires lot of time for decision making and there is a chance for errors. Now, so what we want to do that, we want to replace this human being within a computer and a digital computer. So we want to replace with in a computer. Means given an image to this computer, it has to say that this will contain animal or not. How beautiful it is. Means instead of the human, a machine is doing this classification task. Yes, it will do, but question is how this computer knows the knowledge. How this, because unless until this computer will have certain knowledge, we cannot do this, because it's similar to this, your humans have that knowledge. You see, the humans have that knowledge. So humans having such knowledge, how the humans have obtained this knowledge? Because of their experience in the past, obviously, because of their experiences in the past, right? So the question is, if the same knowledge is transferred to here, the same knowledge is given to this computer, definitely it will do this classification task. And depending on the, obviously the computer, the computational power, the speed of the microprocessor is nowadays very good. So they will make the faster decision making. And compared to the human, so this is subject to when there is a huge amount of data. Suppose say if I given 1 lakh of images for a classification task, the computer may do in 1 or 2 seconds, or maybe it's depending on speed. Some may will take about 2 to 3 minutes, but the man will require definitely 1 day. Imagine how fast the computer is making the decision. So this is the advantage of the digital computer and enabling them to learning or to obtain the knowledge. So if this knowledge is given to this machine, definitely it will behave like a human being. Instead of human being, a computer will make the decisions. And the faster and reliability is also good because computer will never do the mistakes as long as your program is correct. Right. The question is how this computer will acquire this knowledge. How this computer will acquire this knowledge. So there is a data. If you look at, so there is a data, means like your 1 lakh images, whatever you are saying, there is a data. So there is a data, and this data is given to your computer. This is a computer. The computer will read this data, and process this data, and start the learning the from this data. Start learning the knowledge. Once it will learn the knowledge, then it is sufficient enough to make the decision. Question is here the everything, the learning process or reading of the data. Once you read the data, and it has to start learning from this data. So how this learning happens, how the learning happens with the help of this data is we have to program it. We have to program it. Suppose if there is a program, you have written some lines of the code. So what this program has to do, the program has to read the data. And about the output, once it read the data and do some process, it has obtained some knowledge. And with the help of this knowledge, it can do classification or regression, perform the classification task. Right. So if you take any program, so that the input is the data and output is the knowledge, and this knowledge is very helpful in making the decision. It's very good. Now, what is the role of this program? The program role is it will make the computer learn. So this program, how it will make the learn? It will take the data as input and it will do some blah blah inside. We'll talk about what is the blah blah and what is that inside the program. So now I can summarize that there is a program. So the input for this is the data, and I'm putting it together. This is output is a knowledge. So how this the program? So this program is called machine learning algo, or you can the program or model, whatever you call it. It's called a model in the machine learning terminology, in AI terminology. So this program is nothing but the model. If you take any model, by default, the input is the data, output is the knowledge. So there are different type of models are there in the literature. maybe in the Dr. Morning, Dr. Sir has covered, like Navy base or KNN or SPM, some other classifiers. I don't know whether Sir has covered decision tree or not. Sir has covered decision trees? Yes?
Yes, sir. He introduced the topic. Yeah.
Okay, okay. So, if you look at it, maybe by this time you are familiar with what is the KNN classifier, what is the Navy base classifier. All these are the models. So what is the input for this model? The data, and output is the knowledge. And what is happening inside, how it is enabling, how this program will enable to obtain the knowledge is depending on the model to the model, right? So like Navy base, like KNN, SVM, the ANNs, artificial neural networks, is also one of the model to solve the classification problems. To solve the classification problem. So it means that the ANNs are one of the models, classification models, and ANNs can be used for classification and the regression task. We can use this ANN like Navy-based KNN and SVM. We can also use the ANNs, artificial neural networks, for the classification and regression problems. If suppose in the very beginning I was discussing, one second. Yeah. So here I asked a stockbroker, so instead of stockbroker, you can use the ANN for the regression problem. Instead of the doctor, suppose here, you can use ANNs for the classification task. Instead of this guy, you can use ANNs, artificial neural, for the classification task. Means if there's a classification problem, the problem can be addressed with the help of the ANNs. So that is the background for ANNs, why we want to use study about ANNs. So let us go in detail about how the ANNs are evolved, what is the typical characteristics of the ANNs, and how they will function, and what are the different type of ANNs architectures are available in the literature. One second. So one second. So there is some issue in my stylus. Yes. Now let us see the background of the ANN. So if you look at this ANN, artificial neural networks, so this will take the inspiration of our human brain. The main driving philosophy is behind this is the human brain. So the basic block of our human brain is a neuron, a simple neuron. And there are billions of the neurons are there in the human brain, and these neurons will be interconnected and will create a complex network, and this network will allow you to the learning. So by seeing an image, you can say there is an animal or not. By seeing a chest X-ray, you can say that uh, it's a COVID positive. Or by seeing the stock market price, whether we can decide whether we can purchase or we can sell or we can. So we can make some decisions. How this decision capability has given to the human brain, the humans, because the fantastic capability is a role of the human brain. So this human brain will make you to the learn because of the neurons inside this. The basic building blocks of the neurons will make you, and these neurons will be interconnected with the help of other neurons and will create a complex network. And so this complex network will memorize the things, will process the things, will analyze the things. So similar to this, we want to create an artificial brain to our human brain, to a computer. It's nothing but we are creating an artificial brain, nothing but our machine learning algorithm or the classifier or regression algorithm. So this algorithm will enable what the computer does. The computer simply process. So whatever the data is given, it will process according to the program instructions. Right. Well, that's what the computer does. Computer store the things and it will process these things according to the inline with the instruction. That instruction is nothing but your program. The program is okay or model. So whatever the model says, how you have to learn the things, in line to that, your computer will process and execute the instructions and allow the computer to learn. Right. That's the idea. Now, but question is, yes, it's very simple to say that we want to create an artificial brain to your computer. The question is how. So there were two people. They closely observed the human brain and the electrochemical reactions of this human brain, and they created an equivalent artificial neuron. They created an artificial neuron, so which is equivalent to the neuron which is there in the human brain, which is there in a human brain. So they closely observed this, the human behavior pattern, and this human brain pattern, and they come up with a mathematical model. Okay, so those two people names are McCullough, see, McCullough and Pitts. So these are the pioneer in the ANN field. So they laid the foundation for this ANN architectures. So they found that they came up with a mathematical model uh, that is equivalent or almost equivalent or mimic uh, the 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 natural neuron or the neuron which is there in human brain. Now, so how they came up with such kind of mathematical model? What is the actual mathematical model? We will see now. So we'll come back to this slide. So if you see, so this is the neuron which is there in human brain. Which is there in human brain. So to see with the help of the microscope, so this neuron will have some central part is called nucleus, and it will have some axon, and there's some tail like axon, and this axon you will have some what is called dendrites, and these dendrites will have at the last it will have some synaptic way synapses. With the help of the synapses, so we can connect And with respect to another, this is another neuron, this is another neuron. So right, so this is another neuron. So we will connect. So this is with help of the synaptic weights or synapses. So we will connect. So what they observed that, so this is my how they model. So they called this is a central part, and this neuron is connected to the synapse with help of synapses. The synapse to another. This is another neuron. There is a neuron and there is another neuron. So these are connected with help of synapses. Okay, synapses. Right. It's similar to here. This is a neuron. Okay. This neuron will have this neuron and this neuron, something like this interconnection with the help of synapses. Okay. Right. Now, so where the information is coming to this, at some point, so these neurons, the brain, the human brain, will have some inputs from the different parts of the body. And if we'll have some outputs, and outputs will go to the different parts of the body. We don't know number of inputs and outputs. So once this is called a signals data, input signals, this is called a data, and this is called output signal. Again, it's the data. This input signal data is coming to this network. Inside this, there is a huge neurons. They are connected in some fashion, and there is a output coming from this. So both input and output is a signals. Okay, and what they observe that whatever is coming as input, whatever is coming as input is not same as the sum of the output. Okay, so the output, they observe the try to find the relationship between the output to the input information. What they found that it is not simply the output information. Output is not the summation of the input. There are multiple inputs. The output is not simply the summation of the inputs. So there is some the transformation between inputs and outputs. So, right. So what they did, so this is they what observed. Okay, so there is no there is transformation required from the input signal to the output signal, and so synapses with the help of synapses it will connect to the other what is called neurons. With this observation, a simple mathematical model I can write like this. So there is a neuron, and there is a neuron, and there is a neuron. So this information is coming from this neuron. Information is coming to these neurons, and there is output. So this is the input. So I1 to IN. So if you observe here, let me reframe. What we can observe that the output is not simply a summation of inputs. So what they observe, there is some transformation. Hence, for that reason, so they kept a function. The function, so the summation of input has to pass through this function to get an output. Is I1 and I2, and as a mathematical model, and so it requires some the learning process, and it should represent the knowledge in the form of the weights. That's the reason they will have some synaptic weights between the any two neurons. So there is an interconnection, means there is a weightage for this interconnection, and so in a high level view, they have given such a mathematical model. So this mathematical model will have inputs I1 to IN, and each interconnection between these inputs to the neuron will have some synaptic weights like W1 to Wn, and you will get first you will find the summation of the weight of the connection into the input signal W1. So like this, you will find the summation of collection of the summation of what is called input weights, and this this sum value, this sum we can call it as summation of I into Wi. So I running from 1 to n, something like that. So this sum value we are passing as input to the function. Let it be f. So the f of sum, we don't know what is this function, is your output. Is your output. So this kind of mathematical has been proposed by those two guys who was found who are the pioneer in the field called McCullough and Pitts. That's why so this neuron is called McCullough and Pitts neuron. McCullough and Pitts neuron. Okay. Yes. So this was so there is some neuron. So the summation of input and this will undergo the some function. Okay. So this function is called activation function. So this function is called activation function. We will discuss the right point of time, what is the role of this activation function and all. So as I said, there is some multiple outputs or single outputs, and there is a multiple inputs, and these inputs will have synaptic weights, and this will getting multiplied. This is your total input, and this will undergo the activation function, right? G of input I function. See here. So whatever I said is the same thing. Now let's have some background, some information about these all this stuff. Right. So McCullough and Pitts in the year 1943 are generally recognized as the designers of the first neural network. So many of their ideas still used today in the form of the deep learning. So nowadays everybody is using a deep neural networks. It is an advanced version of of your neural networks. Okay. So in the year 1949, so Hebb developed the first learning rule. So what is the role of the learning rule? Suppose there is a neuron and it is having a weights W1, W2, and there is output. There is input n. So this is a summation, this is the activation function. If you look at this, how these weights are fine-tuned. So what is the value of W1? So what is the value of W2 such that when I multiply this I1 into W1 plus I2 into W2, I will get correct output. Correct output means, so it may give some wrong output also. So it means so there is an error. There is an error. So when you compare this output with the actual output, so what is the value of this W1 and W2 such that you have to minimize this error, because this error should be as minimum as possible. So what is the value of W1? What could be typical values of W1 and W2? Who will decide this? Who will fix it? So these values will be fixed with the help of in a program. The program is called learning algorithm. So every learning algorithm will follow a learning principle. Means so this principle will tell you how to update the weights. Means whether it has to increase the weights or it has to decrease the weights. So towards increasing or decreasing the weights is towards the, it has to minimize the error. It has to minimize the error. Our idea is to minimize the error by increasing or decreasing weights of these synapses or interconnections. So in this slide, there was a person called Hebb who has proposed the first learning rule for updating the whales. This is called Hebb's learning rule. We will see this, okay? Now, so this is not as much. So this then so if you come to the natural brain or a human brain, so it will contains 100 billions of the neurons. You can imagine the complex network, complex neural network. Okay. So a neuron may connect it to as many of 1 lakh neurons. A single neuron is means there is a exist 1 lakh interconnection. So you can imagine the complexity of the human brain. Because of the such complex network, only we are able to learn. This part I already covered. Yes. Now let's come back here. Now, so this is what we have seen. There are activation functions. So what is the role of this activation function? Why we require this activation function? So one is for transformation. So what is this transformation? Non-linearity transformation. So there exists a non-linear transformation between input to the output. Hence, we can use non-linear activation function. So once we pass the value to this non-linear activation function, so we'll have a non-linearity in your system or neural network. The another reason is to squeeze the output values. To squeeze the output values in certain range, like 0 to 1 or minus 1 to 1. So whatever is this value, some value, the output will be either 0 to 1 or 0 or 1 or 0 to 1 minus 1 or 1 minus 1 to 1. What do you want? Whether you want 0 and 1, so you have to use threshold logic or called step activation function. Suppose I want my output should be not only either 0 or 1, it could be anything, any value between 0 and 1, then you have to use sigmoid activation function. Sigmoid activation function. Suppose if you want to you are required, you want to minus 1 to 1. I want minus 1 to 1 means either minus 1 or 1. Then I have required which one threshold logic function, you can use it. And what is this? I want to use minus 1 to 1. Then you have to use what is called tan hyperbolic. So what is your output range? Where do you want to place? So depending on that, you can select the suitable activation functions. So starting from the threshold logic activation or step activation function to the recent years, we will use what is called a ReLU activation function in the deep neural networks. The deep neural networks, we will use ReLU or tan hyperbolic activation function very extensively. Okay. So we will extensively use this ReLU and what is called tan hyperbolic activation function in deep neural networks. Okay. Now we will come to what is the deep neural network soon. Now just now we have seen the role of the activation function and different type of activation functions, and we observe that any neuron will have inputs and these inputs will have interconnections to the neuron, and every interconnection will have certain weights, and every input is multiplied with the weight. Such a summation of the signal is passed to the what is called activation function. So depending on your problem, you can choose the activation function. Right now, so how we can create now? We have seen a simple neuron. Simple neuron has been created. If you look at a neuron has been created, and this neuron will creates such neurons can be replicated and will create these interconnections. Then you will have different kind of architectures or models. Different kind of architectures and the models. If you see, if you look at one of the classification is the type of connections. Namely, the feed forward and other one is the feedback. What does it mean? So in the feed forward, the data is flow in only one direction, and the feedback, the data will flow in both the direction. That's it. There is a movement of the data in the both the directions. Then it is called feedback. And right. If you look at uh, what is the feed forward connections? Okay. So let me have a diagram. So in the feed forward network, so what will happen is in the feed. One second. So there are different type of activation functions. And if you look at what is the feed forward connection, so there are neurons. Suppose there are neurons, the connections of this a neuron in next level. Suppose if you are organized the layers architectures, layer one, layer two, and there are some layers. Okay, if you are organizing your neurons in a layered fashion, so this is layer one, layer two, layer three, and layer four. And if you are observing these interconnections, the neuron in the next level will have interconnections from the all previous layer neurons, something like this. If you look at this neuron, what is called L21, the layer 2 first neuron will have interconnection from L1, L12, L13, and L1N. So this L21 neuron having interconnections from all its L11 to the L1N, similar to the every other case. So this is called a feed forward connection, means the data is flow in only one direction. Suppose if at all, if any back connection, suppose the data is flowing in one direction. Suppose if at all the data, if there is a data flowing from this neuron to this neuron or this neuron to the same neuron in the same network, in the same layer, then we can say that the data is flowing back to the previous neuron. Suppose if there is a data is flowing here from L11 to the L21. Suppose there's a data is flowing in this also, then we can say that it's called a feedback connections. Okay. So if the data is flowing or if the information is flowing in only one direction, in this case, information is being processed, then it is called feed forward. Otherwise, it's called being feedback. So the one of the famous techniques in the feedback connections is the recurrent neural network. It is called it's a feedback neural networks. And the feed forward, we have so many varieties of the feed forward neural networks. We will study one by one. Right. Now, so far we have seen about different how the neurons and what are different type of architectures are built with when you are connecting multiple neurons like feed forward and feedback. And in the feed forward neural networks, the activation function I already discussed. Now, so what is here there? So we'll talk about the different areas. If we take a single neuron that's called McCulloch-Pitts neuron, it will have some inputs and it will have an output. Okay. Let us look at how the single McCulloch-Pitts neuron can solve different kind of problems. If a single neuron is able to solve these problems, so you can imagine how the complex networks, like feed forward, feedback networks, where you have so many neurons are there, how they can solve the complex problem. We can imagine easily. Now let's see, in order to understand the capability of the neurons, so let's see a single neuron, how we can solve it for the solving different kind of problems. Okay, now let us start our discussion with the end problem. Here, yes. Yeah. If you look at here, what I'm trying to do that this is my single neuron, this is my inputs, and this is output. So this single neuron is trying to mimic the behavior of the AND gate. So what is the AND gate? The input both are 1, the output is 1, and if anything is 0, is 0. This is the output. So when I give 0, 0, it has to give 0 output. When I give 1, 0, it has to give 0 output. When I give 0, 1, it has 0 output. 1, 1, it has to give 1 output. So that is the functionality of the AND gate. How we can accomplish with the help of this, what is called a simple neuron. Right, simple neuron. Look at here. So what they are saying that you take forget about how these weights were fine-tuned. So forget about that, but we assume that there are weights. So 1, 1. Suppose if my input is 1, 1, 1, then its value is, so 1 into 1 plus 1 into 1. So means its value is 2. Right. So when the output is 2, the sum is 2. So what is my expected output? Y should be 1. Okay. Now, if anything is 0, so 1 into 0 plus 0 into 1, 1 into 1, it is 1, then in the case 0. So this is 1. In the case 0 into 1 plus 1 into 1, it is also 0. If both are 0, 0 plus 0, it is 0 and 0. It means that when my output, the sum value is less than or equal to less than 2, is less than 2 or less than 1.5, or whatever you say 1.5, then the output should be 0. And if it is greater than 1.5 or 2, or greater than or equal to, I can say it is it means that if I am putting some threshold, I'm putting into what does it mean that if you look at this activation function, so this some value has to go through activation function. So once it going through activation function, once it's going to activation, this is the output. Means this sum has to go through activation function. So y is the output, something like that. So if I give 2 as an output function, it has to give 1. And what is that activation function we are using is here threshold logic activation function. So according to the threshold logic activation function, so if my threshold is greater than or equal to 2, if it is greater than or equal to 2, then output is 1. If the sum is less than is 2, then output is 0. Yes, you see. When I am setting threshold 2, it exactly behaving like an AND gate. Because when the sum value is, what does this threshold value say that? It's a threshold logic activation function. According to this function, what is saying that the sum is greater than or equal to, the output is 1, less than 2, the output is 0. This is threshold logic activation function. Means a single neuron with a single neuron is solving the AND gate problem. A single neuron is solving the AND gate problem. Okay. In a similar way, a single AND gate, a single neuron is also solving our problem. But the question is, the weights are different and the threshold, of course, are likely same, but it could be any threshold value. So with the, in the earlier case, the function, so the same network, but the only thing is weights are changed. So that's why, so these weights are called hyperparameters. Weights with threshold are called hyperparameters. What is hyperparameter means? They will change from problem to problem. They will change from the problem to problem. Right? In the earlier case, it is 1 comma 1, now it is 2 comma 2. Right? The same neural network can be used solving a other problem AND NOT gate, NAND gate, or AND NOT gate, whatever you say. Right? No. Right? But the same AND same is not able to solve exclusive OR problem. So what is this exclusive OR problem or exclusive OR gate? Is if the both are one, if both are one, both are equal, the output is 0. So x1 is x2 is equal 1 comma 1 0 and 0 comma 0 it is 0. In remaining cases, if at least one, then we can say the output is 1. This is true if at least one is true, either or something like either x1 or x2. Right. So for this problem, if you want to solve this problem, you cannot a single neuron cannot be sufficient. Single macula, if you want, you can try it. A single neuron cannot be sufficient. But to solve this, a single OR gate or NAND gate or AND gate, a single neuron is sufficient. A single neuron is sufficient, but to solve the exclusive OR problem or exclusive OR gate, single gate is not sufficient. So what could be the reason for this? The reason is, if you observe the data from here, if I'm trying to plot on 2-dimensional axis, of course x1, x2, so what both x comma 1, this is 0 comma x is equal to 0, and this is, yes, if I'm trying to plot here, this is 1 comma 1, this is x axis, y is 0, 1 comma 0, 0 comma 1, and this is 0 0. If I draw the class labels, of these samples, you look at here the class 0 comma 0 is 0, 0 comma is 0, 1 comma 0 is 1, no problem. This is 0 and this is 0, no issue. If you draw a straight line, so below the straight line we can say, for simplicity purpose, above the straight line the class label is 0 and below the straight line class label is 1. Means this data is separable by a hyperplane or a straight line. I can divide this data into two categories by drawing a simple straight line. So such kind of data is called LSV, linearly separable data. Linearly separable data. So this data is linearly separable data. In OR case also you can check it. This is also linearly separable data. In this case also it is indicate also it is a linearly separable data. So what we can observe that if the data is linearly separable data, a single neuron is sufficient. Of course, it should be a binary classification problem. So if the linearly separable data exists, again a single neuron is sufficient. If you observe the exclusive R two-dimensional space, the two-dimensional space, this is 0, 0, 1, this is 0, 1, and this is 1, 1. So if I put both are 0, this is 0, 1, 1. So can I separate these 4 points or such that two zeros are one side and two ones are one side in the single straight line? Can I draw a straight line, a single straight line such that I can separate the two groups, the 0th group and first group, or 0th class or first class? How can I draw with straight line? If whatever you draw, you cannot draw, so hence you require at least two straight lines. At least two straight lines are sufficient. So hence means that a single perceptron is not sufficient. Okay, you can visualize a single perceptron is nothing but it is drawing a decision boundary in a linearly decision boundary so that we can easily separate the data. But in the case of this, the linearly, so the exclusive R data is called non-linearly separable data. Sometimes it's also called non-linearly separable problem. If the data is non-linearly separable, a single neuron is sufficient. Hence, you have to use networks. You have to combine the multiple neurons in a different kind of fashions. So if you look at here, 1, 2, 3, 4, 5 neurons are there, they are connected in some topological fashion. So this is now a network. A neural network is required if the data is not linearly separable. If the data is linearly separable, definitely a single neuron will solve your problem, hence you don't require it. So let's have some 10 minutes break, then we will resume our session. Let's have some 10 minutes break, then afterwards we will discuss. We'll continue. Let's have some 10 minutes break.
Okay, sir.
So welcome back to the session. So we found that for if the data is not non-linearly separable, so definitely there is a need of the network. Okay, so we have to combine the multiple neurons with a different kind of topological fashion. Okay, so there we arrived at we discussed about the feed forward and feedback networks. Okay. In the feed forward networks, the feed forward networks, um, there is a flow, the data flow in the information flow in the one direction. The feedback it is in to and fro directions. Okay, in the both directions. Now let's see what are the different type of networks, different kind of feed forward neural networks are available in the literature, and all of them can be used for the classification problem and the regression problem. Last I will discuss it. Okay, how we can model the model, the classification problem, that is the solution. Look at if you look at the feed forward networks, neural networks are called FF neural networks. One of the famous one is called multi-layer perceptron network. Other one is multi-layer feed forward neural network, and other one is RBFN. Other one is probability neural network. Other one is PATM. There are so many. TDM and all. So if you look at the MLPN, the multi-layer perceptron network, this is called P stands for perceptron. What is this multi-layer? Means there are some layers. Some layers. There are some layers. And this layer fashion, we will organize your, it's called a neuron. So there are so many neurons in each layer. The first layer is called input layer, and the last layer is called output layer. So these are called hidden layers. So the simplest network will contain at least one hidden layer. So hidden input layer and output layer are default. So a simple network will contain at least one the hidden layer. Right. Now, so what is the perceptron? How it is different from ML, FF, and N? So before I arrive at how it is differ, so what are the activation functions? Are there? Suppose I am giving input I1, input I2, input I3, input I4. So whatever is given should has come as output. This is whatever is giving. This is IN. And once we have these inputs, so you know it's a feed forward connection. So it has a connection to this. It has a connection to this. It has a connection to this. This is a connection. Means these neurons will have input from I1, I2, and IN. Each will have weights W1, W2, W1. And once we get the sum value, what is the sum value over here? Summation of, what is the sum value? Summation of sum value over is summation of I into WI. I runs from 1 to N. So this sum value will undergo some activation function. The activation function here is called threshold logic. What is the threshold logic activation function or step activation function? The step activation function, the sum value, if sum value is some threshold, this is 3, is +1 is 0. Means if this is called x-axis, will have sum. If sum less than t, the sum value is less than t, the output is 0. Sum value is greater than or equal to t, the output is 1. Means you are restricting the output to either 0 or 1, or we can use so. or you can use step activation. With the step activation, threshold logic activation function, or you can say it is -1 also. Instead of +1, you can make it -1 also. So if you are restricting to either 0 or 1 or -1 by the help of threshold logic activation function, so this network is called a perceptron network. Multi-layer perceptron network. Yes. So if the hidden layer activation function is threshold logic, all the in this hidden layer ko threshold logic TF threshold log 3F threshold logic. Now let us come to the activation function at the output layer. The most of the times the activation function at the output layer is a softmax. What is the softmax? So this will have some value. So e to the power, this is sum 1 and sum 2 and sum 3, right? So e to the power of sum 1 by e to the power of sum 1 plus e to the power of sum 2 plus sum. We are normalizing. So e to the so the value, the output value of this, the first neuron divided by the output values of all the neurons in that layer. Right. This is what is called softmax function. So once we get a softmax value based on whichever value is maximum, that based on that we can classify it. Right. Suppose the question is how many number of neurons will be. Suppose there are so many number of neurons I kept in input layer, output layer, and hidden layer. So what is the number of layer neurons are required in the input layer? The number of neurons required in input layer is nothing but dimensionality, or nothing but number of features. Dimensionality are the number of features in your data. So when you are talking about data, you are always talking in terms of what is the dimensionality and number of classes. The dimensionality is the number of features excluding the class label. So what is the reason of keeping your data the class label? What is the class label? Is ground truth information. Suppose when I'm saying about image, whether there is an image, so whether it is having animal or not. So to train your model whether it's animal or not, first you should inform the model that so whether it is containing the animal or not. So it's in the same way, if there is a set of features, you are saying that yes, it means that this particular image is, these are features related to the image and this is the class label related to the image. This particular image is containing animal S, because this information will help you to train your model, to make model to learn by adjusting the weights and all, right? So this class information. So the number of features will be determined by the dimensionality. It's called dimensionality, and this will determine the number of neurons will input layer. Now, if the number of neurons in the output layer is decided by the number of classes, means if there are two classes, there are two neurons, and each neuron will give the some value, and whichever value is maximum, based on that we can say that the image. So if this neuron belongs to S class and this neuron is belongs to no class, suppose if this output value of the S neuron is more, means the image belongs to S class, it containing animal, something like that. So now we identified that the activation function here is softmax. Here it is threshold logic. Here it is a threshold logic. What about input layer? If you observe the input layer, whatever I am giving as input as coming as output. Can you guess what could be the activation function here? So what could be the activation function over here? It's an identity activation function. What is identity function? Whatever is given input, same as coming as output. So the identity activation function here, threshold logic, here is softmax activation function. And we identified the number of neurons in the output layer and the number of neurons in the input layer. What about number of neurons in the hidden layer? So this is called model or MLP and fine tuning. So first what you have to do, in the x-axis, you have to take the number of neurons in the hidden layer. You can keep on gradually increasing. You can, on the other hand, can take the performance. Initially the performance may be, error may be high, gradually it is decreasing. So at which point of time it start decreasing, so that you can consider at some point it will be stagnated, I mean stable. So there is no much change in the error. Then you can treat that particular region, that point, starting point, as your the optimal number of neurons required for your hidden layer. So this kind of model fine tuning process. Right. Now, how we can make use this MLPN for the classification task? How the MLPN used for classification task? So you have a data. So this data is given to your model. What is this model MLPN? So there are inputs, input layer, hidden layer. In this case, I have taken only one hidden layer and output layer. You know what is the activation functions in each and every layer, and there are interconnections. And so what is the input for this? The input for the features, and the number of neurons in the output is the classes. This is the classification task. There is a classification task. So this image or features are given to this input layer and it will get processed, and based on the class label information it will identify the error, and based on this error it will adjust the weights such that for which set of weights you will have the minimum error. So based on this it will either increase or decrease by using some learning algorithm. So one of the famous learning algorithm is the backpropagation algorithm. Okay, so I'm not discussing backward, just I'm giving hint. So this is a learning algorithm. So with the help of this algorithm, you can train your model and adjust the weights so that it will gain the knowledge. So the question is how we have modeled for the classification task. Yes, like this. But what about the regression task? What about regression task? Any idea? What changes I have to make if I want to use it for the regression task? The same data. If you see in the classification task, so there is a class label, so which is a discrete quantity. The number of discrete values or number of classes will determine the number of neurons. But where in this case, the output quantity is a continuous quantity and a single neuron is sufficient to get this continuous output. Right? So hence the regression task, the output layer will have single neuron. If it is a classification problem, the output layer consists of number of neurons is equal to the number of classes. Right? So this is what ML PN. So now what about multi-layer feed-forward neural network? How it is different? The only difference between MLP and MLFFN is just change the activation function. The activation function, instead of here, what is the activation function? Threshold logic. Change the threshold logic to the sigmoid activation function. Means the threshold logic function, the output is either 0 or 1, but here it is a 0 to 1. 0 to 1. So when you change the activation function, you are making the decision boundary more smoother by introducing the activation function, sigmoid activation function. Then it becomes a multi-layer field for a neural network. Here the number of how many number of hidden layers? There is no restriction on that. One input layer, one output layer. You can keep how many number of hidden layers when you want. If this number of hidden layers are more, then such network is called deep neural network. So training such, suppose hundreds of, 200s, thousands of deep neural net, that is called hidden layers, if you keep to train such thing, and standalone machine or a general CPU is it will take lot amount of time, and hence we require certainly the GPUs where you will to run this deep neural network. Certainly we require GPUs to get the faster output, right? But this MLP and MLFFN we can train typical, which consists of 100 or 20, 10 or 20 neuron deep neural layers. We can finish it. We can train on a CPU. Now, the same MLP and FFN also used for the classification as well as regression problem. If it's a regression, single neuron will be there. If the classification, number of neurons will be the number of classes. Okay. Now, stock. If you look at here, these two neurons, the MLFF and MLPN, the first information will flow in one direction. It will identify the error. Based on this error, it will adjust the weights. And this process is repeated. It will do it for, so the one such to and fro step is called epoch. So it will run for multiple number of epochs. Hence, to train this network requires a lot of time. You have to wait for a lot of time. Even on the GPU also, even if you are talking CPU. Means what I mean say that you have to train this network multiple number of iterations. In every iteration, it will go through the entire data set and will try to learn. So this is called iterative approach. You can say it is an iterative approach. To counterattack this iterative approach, which certainly require much training time, so there is a non-iterative ENNs. What are these non-iterative ENNs? The first one is RBFN, the radial basis function network. So every neural network, the number of neurons, we can use it for both the classification and regression problem. If every neural network will consider output layer, the number of neurons in the output layer is 1 if it is a regression problem, and if it is multiple, depending on number of classes, if it is a classification problem. For every network, MLPN, MLFFN, RBFN, whatever I am saying. So what is RBFN? R stands for radial basis, B stands for basis, forward radial basis activation function neural network. Radial basis function neural network. What does it mean that RBFN means? So here you can say that it is an activation function is the radial basis function. What is the radial basis? 1 by square root of 2 pi sigma into e to the power of minus x minus mu by whole square by 2 sigma square. This is the Gaussian this is called Gaussian function, Gaussian curve. Okay. Yes. So this is the Gaussian function. It's called a Gaussian function. So it means that we are using the radial basis function as activation function. So this is the radial basis function. So if you're talking about architecture, it will have input layer and only one output layer and one hidden layer. And we know that the activation function here, it is either softmax or depending on the problem. Here it is what is the activation function? Guys, identity activation function, identity function. Here it is a Gaussian activation function or RBF in the hidden layer. In the hidden layer, if you are using Gaussian activation function, then it becomes an RBFN. And of course, there is a restriction on the what is called number of layers, hidden layer, no, only one hidden layer neuron. And there is one interesting thing over here is, so there is a weights. So there is a weights over here in between the hidden layer and output layer, and these weights will be calculated using matrix inversion principle. How? Because you will have a Gaussian outputs, so that is called pi, and you have a weights W. This is called the output is your target. So W is equal to the pi inverse into T. What is the pi? It is in a matrix which contains all the activations of your Gaussian neurons, Gaussian layer neurons. And you have to inverse that matrix and multiply with the T such that, what does it mean that whatever what Gaussian value has to multiply with the what for what W values I have to multiply with the Gaussian so that I will reach my target. What is my target? My target is either if it's a S class or no class, means 1 or 0, something like should be 1 or 0. So it's like system of linear equation, and solving the multiple system of linear equations, you will find these the weights. Okay, it's a simple by using matrix inversion principle, or you can determine. But what will happen? The problem is that if the pi is 0, if it's a det is 0, if it is a singular matrix, then the problem is finding out the pi inverse is very difficult, and that's why we will use pseudo inverse. And this, in that case, you will use pi plus t. This is called pseudo inverse when the pi is a singular matrix and all this. And there is another version is called ELM. So what is this in the extreme learning machine is, in this case, the number of hidden layers neurons are generated randomly. The number of hidden layer neurons are generated randomly, and accordingly it will find the weights. Okay. So it's, there is some random it's almost similar to the RBFN, and the only thing is it will have some randomness. The number of hidden layer neurons is not fixed. It will change dynamically as and when you require ELM. Okay. So these are all, if you require, solving this system of linear equation, you can finish in fraction of seconds by using tools. So it means that maybe here we are not bothering how much time it takes, but in a single iteration. So in the first iteration, it will find all its pi, and in the pi into what is the value of this W, you have to reach your target, or your class label. So once you get this pi, once you get the pi, remaining process is very easy, and this the W is equal to pi inverse into 3. So it means that in a single iteration we are finding the weights. What are the weights? The weights are nothing but your knowledge. Very, very important. The weights represents knowledge. In this case, the weights will represent the knowledge. Okay. So this is another, and other thing is, so there is slightly modified version of RBFN. There is no weights here in this. So maybe they will use probability distribution functions in the as activation function. Then it is called probability neural network. It's again a non-iterative model. You require a single iteration. In a single iteration, you can finish your task. Okay. So what else? So we have discussed about what is called MLPN, ML, FFNN, RBFN, the PNN, and ELM. So in the ELM, only thing is the input layer is fixed, output layer is fixed. This is dynamic. The number of neurons will be generated dynamically, and according to that, you will find this matrix inversion principle. And of course, it will generate these weights and this. Suppose your weights will be there here also. What it does, it will generate the number of hidden layer neurons and its corresponding weights. So these weights will be generated randomly, and these weights will be calculated using matrix inversion. The only thing is the number of neurons, hidden layer neurons, and of course, if this is dynamic, means the corresponding connections is also dynamic, and the corresponding synaptic weights is also dynamic. Okay, this will be fine tuning. Okay, so this is the non-iterative models, and whatever is the neural network we are using, we can use it for solving the classification and the regression problem. Okay. So there is a small assignment for you. Please think of it. So suppose, as I mentioned, so there is an image. Okay, there is an image. Suppose this is 1, 2, 3, 4, 5. Kind of 1, 2, 3, 4. So it is a 4 cross 5. So if each pixel is a feature, there are 20 features. Each 20 features. But out of these 20 features, I want 10 best features. I want to identify the 10 best features. What are those? I don't know. So this problem is called feature selection. Right? So this problem is called a feature selection. Now I introduce a new problem. Is called, apart from the classification and the regression. So now introduced feature selection problem. How we can use the neural networks for the feature selection problem. We know how neural networks can be used for classification and regression, but how neural networks can be used for the feature selection problem. So that is the assignment, and please think of it, and I will discuss in the next class. With this, I'm closing my session. The last 15 minutes are there for the queries. Please let me know. Guys, if you have any queries, please post in the chat box or you can unmute and speak.
Sir, I have a question.
Yes, Estelle.
Yeah, so the last sheet that you have written. So we said we use the matrix inversion to find out the weights, right?
Exactly, yeah.
So we don't know the output, right?
We know, right? That's the class label, right? We know output. That's called so classification and regression is called. I think I forgot to mention, but it's a supervised task. Why it is called supervised task? Because just I will use the alpha summing. Suppose the output is this is the output layer neuron. So this you already know. Suppose this is 1 0. 1 means it is it's containing animal.
Okay.
0 1 means it is not containing an animal, not containing. So when you use these weights and all, you will get some activation function. Okay, you will get some output from this. So accordingly, you will after threshold value, after applying threshold logic, suppose you got a 0 here, but you are supposed to get 1, but you got a 0. So this will give an error, right? So so this is called a supervised task. Okay, like this. There's a ground truth information. This T is a ground truth information. It's a matrix which containing 0 1 or 1 zeros.
Okay.
The truth is available. Otherwise, we cannot find. So our idea is to. So what is the what values of the W I have to multiply with this pi matrix such that I will have accurate predictions T.
Okay. Okay. So this
The
is
system
like
of linear equation, nothing but.
okay. So this is like the training data kind of thing. So we
Yes, yes, yes.
know, oh, we know the classification and then we are training.
Yes, we definitely we must know the target. Otherwise, it won't be trained. Okay.
Okay.
How we will learn? Suppose simple logic is suppose I don't know by birth what is an animal and what is a tiger, what is a lion, and how I learned. Maybe I've seen in the zoo park. I might have seen in some movies or some might have seen in my pictures and daily life somewhere. And then when I've seen, I memorize the thing. So that is a target. Okay. So suppose first time I don't know what is a lion. I will say that this is a dog. Then what teaches it is not a dog, it is a lion. So there is a correction that is called. So when actually it is a lion, I am saying is a dog. So this is error. So this error I am trying to minimize. How I am minimizing? So when I'm trying multiple attempts, first way I say dog, next way I say it's not a dog, something like the last way after 10-15 attempts I may say it is a lion, because there was some instructor, the teacher, she is saying that when I'm saying correct answer or wrong answer, that correction is there. Same lines, in the similar lines, the neural networks will be trained with the help of targets.
Okay. Yeah, and one more thing, what kind of inversion techniques do they generally use? So,
Matrix inversion, matrix multiplication, matrix. How you will find the matrix? If there is a matrix A, how you will find A inverse? That's it.
okay, I mean, sometimes they use this numerical methods, right?
You
Whether
can
they,
use depending on you can use nowadays. I mean, even you can use this what is called bio-inspired computing or genetic algorithm for finding out these weights and all. But most of the times we can use simple matrix inversion. Okay, how we'll find the A inverse? Okay,
Okay.
that's it. Maybe whatever you studied in our how. So for two-dimensional matrix, 1 by det of AD minus BC, something like that. Similar. But of course, that very simple for 2 by 2. So if it's a 100 cross 100 matrix, then it is very difficult because you have to use
Okay.
matrix theory over here. For whatever is, you write a simple function in MATLAB that will, you will give the input matrix and ask for the det, inverse, it will find the inverse. So the
MATLAB is
functions are available. We need not write any program for that. Just make use of that function.
right.